the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hi guys, welcome to Smart VCAD video tutorial on the course Principle of Electrical Engineering 1. I hope you are having a great day. So today we are having a question on Thevenin theorem. This is an examination question. So we are asked to find the Thevenin voltage across terminal AD. This terminal, we are asked to find the voltage across this terminal, which is the Thevenin voltage VTH. We are also asked to calculate for the Thevenin resistance, and also we are asked to find the current across 20 ohm resistors. We are also asked to calculate the power dissipated by this 20 ohm resistance. So let's quickly dive into solving this question. You should know Thevenin theorem by now. So solution. So to find the Thevenin voltage, let me quickly paste the circuit here again. So this is the circuit that we are having. So to find the Thevenin voltage, we are going to open circuit the load resistors, which is this 20 ohm. So therefore this 20 ohm no longer exists. So we are going to open circuit this terminal. So the voltage across this terminal is our VTH. Let's say a voltmeter is connected at this terminal, for example. So the voltage here is the VTH. So for us to find the voltage here, so if you should get the voltage at this node, that will be the voltage at VTH, because they are in parallel. So let's quickly name this node X. Let's call this node Vx, and this node Vy. So we are going to be using nodal analysis to solve this question. Nodal analysis is the most powerful tool that we have in electrical engineering, so you should know it by now. Let me quickly explain some brief principle about nodal analysis. So using nodal analysis, so nodal analysis is just talking about current. So if you are having I is equal to V over R, so we are going to be representing our equation in terms of V over R, which is the current. So that's what nodal analysis is all about. So if we are taking a node as the higher potential, let's say at this node, so this node will be at the higher potential. Any current flowing into the node will be negative, current into the node will be negative, and current flowing away from that node will be positive. Please take note of this. And also we'll be subtracting the node at the higher potential from those at the lower potential. You should know this also. So let's quickly dive into deriving the equation. So at node Vx, so what are we having at node Vx? So we are having Vx minus 20. This 20, the current across this node is Vx minus 20 all over 15 ohm resistance 15. That is the current flowing in this branch. So what other branch are we having connected to the node? Also we are having this branch connected to the node. So we are going to have plus Vx minus 0, because this is ground, minus 0 divided by 10. So also we are going to be having plus Vx. We are also having this branch connected to the node, Vx minus Vy, because Vy is the voltage across that other edge, divided by 6. So we are also having this branch connected to the node, but there's a current source there, and the current is flowing to the node. I told you current flowing in is negative and current flowing out is positive. So we are having minus 4 is equal to 0. So now this is the equation at node X. So let's quickly find our LCM. Our LCM is 60. So here we are having 4Vx minus 80 plus 6Vx plus 10Vx minus 10Vy. Then we are having minus 240 is equal to 0. So cross multiplying, we are going to have 60 will go. So we are going to have 4Vx plus 6Vx plus 10Vx. We are having 20Vx minus 10Vy is equal to, so if you should sum minus 80 and minus 240, we are going to have 360 minus 360, minus 360 going to the other side. We are going to have 320. Sorry. So we are having 320 at the other edge. So this is our equation 1. So let's go back to the second node to find our second equation. So going at node Vy now, at node Y. So what is happening at this node? How many branches are connected to it? This branch and this branch of the current source. Those are the two nodes those are the two branches connected to node Y, this one and this. So at node Vy now, let's check what branches are connected to node Vy. As you can see, this branch is connected to node Vy, and this branch is also connected to node Vy. Since we don't have anything here, we are not going to account for this. So at node Vy, we are having, now Vy is at the high potential, so we are going to be subtracting other voltages from it. So we are having Vy minus Vx all over 6, which is this resistance, plus now we are having this other branch, but the current source is flowing away from it. So I told you current flowing away from it is positive. So we are having plus 4 is equal to 0. So that is the equation we are having in node Vy. So at node Y, let's quickly write the equation here. At node Y, we are having Vy minus Vx all over 6 plus 4 is equal to 0. So quickly finding the LCM. The LCM is 6. So we are having Vy minus Vx plus 24 is equal to 0. So cross multiplying. So once we cross multiply, we are going to be having Vx minus Vx, and rearranging minus Vx plus Vy is equal to minus 24. So this is equation 2. So now, since we are having equation 2 unknown, we can quickly use elimination method to get the value of our Vx and Vy. So dividing equation 1 by 10. So we are going to have, if we divide this equation, the equation at the top, by 10, we are going to have 20 divided by 10. We are having 2 Vx minus Vy is equal to 32. So now we are having minus Vx equation 2 plus Vy is equal to minus 24. So we can sum this. So summing this, plus we are having Vx is equal to 32 minus 24 is 8. So we are having 8 volts. So our Vx is 8 volts. So we can quickly look for Vy. So our Vx is equal to 8 volts. So looking for Vy, if you use equation 2, rearranging equation 2, Vy is equal to minus 24 plus Vx. So which is equal to minus 24 plus 8. So our Vy is equal to minus 16 volts. So I told you earlier that the voltage across Y, the voltage across Vy is equal to the voltage, our Thevenin voltage, which is equal to minus 16 volts. So our voltage is minus 16 volts because they are connected in parallel. So now we've gotten our A part. So let's quickly find the B part, which is the Thevenin resistance. So the B, for the B part, we are asked to find RTh. So the B part, we are asked to find RTh. So now let me quickly paste our circuit and tell you and explain the principle of finding the Thevenin resistance to you. It's quite simple but very trickish, so you have to be very careful. To find our Thevenin resistance, we are going to open circuit current sources. So note this down: current sources is equal to open circuit, and voltage sources is equal to short circuit. So we are going to open circuit current sources. So this 4 amp is no longer valid, open circuiting. So this 20 volts will be short circuited. So it will be short circuit like this. It is just an ordinary wire there. So this is our resistance, and also we are going to remove our load resistance, which is this 20 is no longer there. So we are having, this is our circuit now, and this is RTh. So the resistance across this terminal is the RTh. So now finding the RTh, now we are going to start from the back. We are going to always start from the back side, which is this side. You find your resistance from this side, not this side. If you should take it from this side, you are going to fail the question. So you take it from the left hand side to the right hand side. So taking our channel now from the left hand side to the right hand side, we know that there is nothing connected at this terminal. This terminal is gone. Since it is being open circuited, this terminal is gone. So now we are having 15 in parallel with 10, and in series with 6 and 4. That is our RTh. So quickly finding this now, we are going to have 15 times 10 all over 15 plus 10, which is equal to 6 ohm, So don't forget, once you find this in parallel, it will be connected in series. So that is why I said that this and this are in parallel and in series with these two. So we are having 6. Our RTH is equal to 6 plus 4, which is equal to 16 ohm. So our B, the B part of the question, is equal to 16 ohm. So now, Thevenin theorem, it says that if you should find the RTH and the VTH, they will be connected in series with your load resistance. They will be connected in series, your VTH and your RTH. They will be connected in series with your load. So they will be connected in series with 20 ohm resistance. So the C part, now we have to find the current. So our VTH is equal to minus 16 volts and our RTH is equal to 16 ohm. So now, since these two resistors are connected in series, so we can sum them together and find our current. So we are having R total is equal to 16 plus 20, which is equal to 36. Then our I total, the total current flowing here, IT, is equal to minus 16 all over 36, and this is equal to minus 4 over 9 amp. So this is the C part. We have gotten the current flowing across 20 ohm resistance. So the D part now, the D part we are asked to find the power dissipated by 20 ohm. So we know that power is equal to I square R. So it is very simple and straightforward. So we are going to square minus 4 over 9 squared, then multiply by 20 ohm resistance, and this is equal to 3.95 watts. So this is our final answer. I hope you understand this tutorial. Thevenin theorem is very simple, but it might be very tricky. Whenever calculating for your RTH, VTH, just be very careful, solve it. It is better to answer 3 questions carefully in exam and get it right than answering the entire question than getting it wrong. So thank you very much for watching this video. We'll meet in our next tutorial. Thank you.